electric potential. It means amount of work done in moving a unit positive charge from infinity to a point, which means V is W upon Q. Now we need to have the measurement of this potential. Yes, electric potential is always measured in volt unit. Now, potential due to a point charge. For this, we assume that we have a point O where we have a charge. Then there are few points around it. Let's say P. The separation of P is R. Then we have 2 points A and B having separation dx, and A is separated by distance x. It extends up to infinity, and let's say we have a charge Q naught. So this is the domain of this charge. So amount of work done from A to B by small distance, small work done is dW, which is minus of F into dx. Minus because it is done against the electric field of a source charge, let's say Q over here at O. So net work done, if you want, it will be F will be K Q naught upon x square dx, integration within the limit infinity to R. R means we want to move it till point P. So this work done, which is in the form of K Q naught is constant, and this will be x minus 2x dx, limit infinity to R. And so work done as K Q naught x minus 2 plus 1 divided by minus 2 plus 1, limit infinity to R. So this work done Q naught, and this minus, let's write it before, minus 1, and it will be x inverse, so we can write 1 by R minus 1 by infinity. Since 1 by infinity is 0, therefore WH let us go like this. W is minus Q naught upon R. Now we divide both sides by Q naught. So W upon Q naught is minus of KQ upon R, and W upon Q naught is V. Therefore, V is equal to minus KQ upon R, which means potential is proportional to 1 by R. And if you plot a graph V R, then this is like this. Hope it's clear. Now in the same thing, we can find potential due to many charges at a point, superposition type. So potential at a point due to many charges. We do like have a point where we want to have potential due to n number of charges. Let's say this is Q1, R1, Q2, R2, Q3, R3, Qn, Rn. and this is the point P, let's say. So at this point P, we take net potential V net as potential due to first, potential due to second, and so on and so forth, potential due to n number of charges. This way we add. Then we have electric potential at any point due to a dipole, electric dipole, right? So what we do, we take a point. First, let us take dipole Q minus Q plus. This is the center of dipole. Point P is, let's say, lying here. If we join P, this is, let's say, A and B. This is R1. The other one, let's say this is R2. So potential at P would be V1 plus V2. When we take V1, let's say due to minus Q charge, it will be minus KQ upon R1 plus, due to this is plus Q, so KQ upon R2. Now what we do, we need to consider the length of dipole. How we can consider, we produce this like so that then we plot a perpendicular if it is M. Now AP and PM are same, and then if this is angle theta, then this is base of the triangle, so it will be, and this is half of dipole A, so it becomes A cos theta. Likewise, you select a point conveniently. Over here it is normal 90. If it is N, so this base will be also A cos theta, which means KQ is common. Let's write this R2 first, which means R2 would be R minus, means 1 upon R minus A cos theta minus 1 upon R plus A cos theta, right? This part is A, which is plus. Now if we solve, KQ is common. Inside it will be R square minus A square cos square theta. So we are left with R plus A cos theta minus R minus minus plus A cos theta, which means R cancel, the 2A cos theta, तो K 2A पहले लिख लेते हैं into Q into 2A will give us dipole moment, तो and cos theta as it is रहने देते हैं, divided by R square minus A square cos square theta, तो क्या बन गया KP cos theta upon R square minus A square cos square theta, right? So this is general formula for potential due to a dipole at any point. If we take special case, the special case would be like for a short dipole, R is greater than A, so R square minus A square cos square theta can be R square, and therefore potential can be Kp cos theta upon R square. This way it is changing. So this way we have done potential due to a point charge and potential due to an electric dipole both. Thank you so much.